Now look, I can tell that you're not bored, but just in case you are, we're going to unboard you by talking about onboarding. Huh? Yeah? By the end of this session, we'll be able to describe the SDA endpoint onboarding process. In a traditional network, if the routes are converged, meaning all of the routing tables are established, the new endpoint coming online isn't a big deal because the subnet is already known by the rest of the network. But in an SDA environment, we don't operate by subnets anymore. We need those EID to RLOC mappings and a new EID, in other words, a new endpoint coming on board. That's a big deal. We need to make sure that the proper processes are followed. In this video, we're going to cover exactly what happens when a new endpoint logs into the SDA fabric. Before we begin, we need a quick definition of terms. If we have a situation where we have tunnels between two switches and we're sending traffic in a particular direction, we are going to define the ingress tunnel router, and then we'll have the egress tunnel router. Now, as is typical in networking, we're going to turn these into three-letter acronyms, and so we have the ITR and we have the ETR. So in our case here, when we're talking from the switch on the left to switch on the right, the local L3 device is the ITR, and the remote layer 3 device would be the ETR. Now remember, Lisp was developed for the service provider where they use mostly routers. And so even though we're calling these ITRs and ETRs, these could be layer 3 switches. But we still like to keep the same terminology, and so we're going to call them ITRs and ETRs. So thinking back to how we tag traffic and enforce traffic, we are going to tag traffic on the ITR because it's on the ingress side. The packet is just being received by the fabric. And then we're going to enforce that policy on the ETR side. So this is great, but the question for the day is, how does this even get established? How does the ITR know where to send traffic? How does it know which ETR to select? Because remember, we're going to have tunnels established to all the other fabric edge nodes in the fabric. So we need to understand which EID is mapped to which ETR. And we remember that we identify specific nodes with the RLOC, that routing locator. And that RLOC is usually going to refer to a loopback address on the edge device. So let's clear our screen here and talk through how exactly this all comes together. So let's say we have a new client attached to the network, and we go through that user authentication process that we just described in the last video. So let's say we authenticate, everything goes well, and I've been given an IP address. Well, this IP address is going to equate to my endpoint identifier, EID. And anyone in the network that wants to send traffic to me is going to target my parent switch as the ETR. So we can refer to this as the ETR in this case. Now the ETR has a job to do. It needs to send a message to the control plane node. Specifically, this message is called a map register. The map register message is going to tell the control plane node that this EID that just logged into the network belongs to the routing locator that belongs to the ETR. Now let's say that we have another client out on the network and they want to speak to that particular IP address, whatever that is. Let's call this IP address A. So we're going to send a packet to destination IP address A, and we're going to send that to the upstream fabric edge node. Well, that fabric edge node doesn't know where IP address A lives. Remember, if this was a traditional network, IP address A would be part of a subnet, and I would check my routing table in order to figure out where that subnet lives, and I would simply forward it on. But in a software-defined access environment, we don't route according to subnets anymore. What we really need to do is get this EID to RLOC pairing so I can know which tunnel I should send it to. So what I'm going to do is I'm going to send a query to the control plane node. This is called a map request. And the control plane node is going to receive that map request and going to do something maybe a little bit unexpected. It's going to forward that map request to the ETR that originally advertised it. And then the ETR is going to send a map reply back to the request. So why doesn't the control plane node simply reply with its own map reply? Well, part of the reason is because we want to make sure that the ETR still considers that IP address to be attached to it, just in case we're out of sync for some reason. And we can actually configure the control plane node to send that map reply ourselves if we prefer to do it that way. However, this is the default behavior in an SDA fabric. Now this edge node here on the bottom right, this is an ingress operation, remember? So we're going to call this the ITR. And the ITR is going to store the EID to RLOC mapping. It's going to store it in the cache, and that cache is going to allow me to send traffic to that endpoint identifier in the future without having to communicate with the control plane node. We don't want to have to reach out to the control plane node every single time I have to send a new packet to that IP address. I want to remember it myself, and so I'm going to keep it in that cache. Now that cache does clear out after 24 hours of inactivity, So if for any reason I don't send anything to that IP address in 24 hours, then I would clear that entry from my cache. Now keep in mind, in an SDA fabric, we already have tunnels formed with all of the other fabric edge nodes. So I already have a tunnel formed with the ETR. And now that I have the endpoint to RLOC mapping, I know which RLOC to send it to. In other words, which tunnel I should send this through. So I'm going to take this original packet, send it into this specific tunnel, and allow it to progress to the ETR. And that ETR will take it, de-encapsulate the packet, and send it down to that endpoint identifier. So what about a wireless process? What does that look like? Well, first of all, we have to worry about attaching these access points to a fabric edge node. The fabric AP needs an IP address, so it will DHCP an IP address, and then the fabric edge node will register that to the control plane node as if it was a normal endpoint. That will allow the access point to form a CAPWAP tunnel out to a wireless LAN controller. Wireless LAN controllers need to be attached to the fabric through a border node or from really outside the overlay. So it's sitting on the network somewhere, and we're going to form a CAPWAP tunnel to it. However, we're not going to send client traffic through that CAPWAP tunnel. Instead, the directly attached fabric edge node is going to form a VXLAN tunnel to the access point. And our client traffic is going to traverse that tunnel rather than going through the CAPWAP tunnel as it would in a traditional network. So now we can talk about a client coming on board. A client associates to that access point, and the access point is going to inform the wireless LAN controller over CAPWAP that it happened. The wireless LAN controller will inform the control plane node about the endpoint identifier, and specifically this is a layer 2 identifier, so we're letting it know about the MAC address. Last but not least, when the host communicates out through this VXLAN tunnel, it will show up on the fabric edge node as if it's a normal client. Therefore, the fabric edge node will send another register message, this time for the client's IP address. So now we're getting the EID for the IP address. From there, it's really the same process, other than potentially that we have to worry about going through 2 VXLAN tunnels, but hey, the network handles that for us, so we don't even have to worry about that. So whether it's wired or wireless communications, either way, we need to worry about this onboarding process to make sure that our end-to-end communications can happen. And with that, you're able to describe the SDA endpoint onboarding process. I hope this has been informative for you, and I'd like to thank you for viewing.